So as I look through some of the recent videos I've posted, the most recent thing I've been working on here is really video output. What can I do with my Zynq-7000 board to get video? Prior to that, I had audio, and prior to that, I was doing some other video work. But really, most recently, what I've wanted to do is get really multiple video outputs off of my board that are easily usable from PetaLinux. And if I look back at the last 4 videos I have here, I had taken my core board and added some additional outputs, an additional HDMI and VGA output. And one of those outputs I was using with a frame buffer in PetaLinux. The other 2 were just raw programmable logic on the FPGA, just doing some sample test output. And that's great. Shows that physically things are working, but really not real accessible from PetaLinux then to use those outputs. There's something more needed, drivers, software, something, right? But then I had gotten those 3 displays working, and I'm good with that. So I've got the display physically tested, 3 of them. But what I was doing as I went through this, was really using the primary display with I would say a proper video pipeline in Vivado. So I would have a block design. I would add in the appropriate components like a video DMA IP block, and that would let me get my frame buffer and everything like that running in PetaLinux. But I could not get my second HDMI output or my VGA output to also work simultaneously with them showing up as a valid output, a valid frame buffer inside of PetaLinux. Well, in this video, I'm going to show you that I have done some further work, and I now have multi-monitor support. And in this video, I'm going to show 3 concurrent video outputs that are working. I'm supporting both native HDMI and VGA, so I could have a few of each, or one of both HDMI and VGA, whatever it might be. For this video, I'm going to have 2 HDMI outputs and 1 VGA output, all working simultaneously. And all 3 of those are going to be available or accessible as a device in PetaLinux, specifically frame buffer devices. And this is what my setup currently looks like. So I've got the main board. The main board has an integrated HDMI connector so that I can connect to that, and that has always worked fine. But then as I've added this little add-on card, I've added an additional HDMI connector and a simple little VGA output. And again, I was driving those in previous videos just with programmable logic, but not really accessing them from PetaLinux, which is what I want to be able to do. What I'm going to do in this video is work with those 3 outputs, and I'm going to just refer to this as HDMI 1, this is HDMI 2, and this is my VGA connector. The HDMIs are supporting, full 32-bit, so 8-bit per, color. And an alpha channel if I want to use an alpha channel, so that's where I'm saying the 32-bit. But they're going to support that. The VGA, though, is more limited. It is 2 bytes of color data, so I'm doing a red, green, blue, 5, 6, 5. So 5 red, 6 green, and 5 blue. And so I've got a little resistor ladder that is doing my digital to analog for that. But those are the 3 outputs that I'm going to use in this video. Now, if I go back to previous things that I've shared, this is kind of the video pipeline that I'm using. So I'm using a Xilinx IP block in Vivado called Video DMA. And I'm also using their video timing controller. They have a streamed video out. I'm using all of that. And then for an HDMI native, I am basically creating my own component. And what I'm doing inside of that is wrapping something that Samir, and this is where it is in GitHub, hdl-util/HDMI, something that he had written that lets you output native HDMI signals. So not a DVI type of signal, but native HDMI. And that's what I showed in the last video, was I was setting up a pipeline in Vivado to do this. Well, that was great until I tried, duplicating this whole thing, having 2 sets of those and having 2 outputs. It seemed like as soon as I tried to enable a second monitor, all of it would stop working. And I don't know if it's something with the whole DRM side of PetaLinux, the driver there that I'm using, which would be a Xilinx one, or something else. But I was kind of getting stuck on that, and I could not get it to work. And so I had posted in the AMD forums. This would have been in like their embedded area support, and had asked a question, and I had gotten a good response from one of the AMD staff that was, what about not using the VDMA, and instead of using that, can I use a video frame buffer read? And that's a different IP block. And so I went through the process of pulling out VDMA in my design and getting a single video frame buffer read output working. And that was successful. So then I tried adding a second and a third, and I do have all of those working now. And so what I'm going to do is just walk through what this looks like, and then maybe I'll walk through the details in a little bit more detail towards the back of this video if you want to keep watching and see some of that. But the main parts of what I'm going to get into is I'm using this video frame buffer read component. I'm using a video timing controller. I'm using an AXI-Force stream to video out. And then I'm using an HDMI component that I put together. So it'll show up as an IP component that I can use. And inside of that, at the heart of it, is this HDMI code that Samir had written. And then I also have a simple little module that will do VGA output if I want to use that instead of HDMI, native HDMI. Now this is a zoom back, just kind of a snapshot or a real high-level thumbnail of what my block design currently looks like. And I'm pulling this up so you can kind of get a feel for what this is before I get into it. And really at the heart of it over here to the left is my Zynq processing system. I have things like the processor resets for a couple of different clock speeds. I have the appropriate connectivity for all the different AXI interfaces, master, slave, and that's what a couple of these blocks are doing. There's a whole bunch of interrupt connections, and you can see I'm using quite a few interrupts at this point. A lot of what you're seeing down here is audio related, so I'm not going to touch that here. But what I am going to get into really for this video is I have a set of these blocks that are coming together to give me my HDMI 1. I have another block of, or set of components in this part of this block design that's for my HDMI 2. And then I have a third set that is for VGA. And they're very similar. So as I walk through one and I go to the next one, there's differences, but they're pretty insignificant or pretty minor. Now to make all of this work, there is going to be stuff I'm going to have to do in the device tree. And so again, with this block diagram that you see here, I'm gonna build that and pull it into my PetaLinux image. But then I've got to make sure I'm loading all the right drivers, configuring all of these pieces, and these are the main things that you're going to see as I get into this. There's going to be the sets of things that show up with REHSD underscore HDMI or VGA, something like that. And I put up the compatible flag here because that kind of indicates what driver am I using. So for the actual display output, I'm using my own driver that I wrote, which really I didn't write it. I grabbed Xilinx HDMI output, an older one they had, and I just modified it, tweaked it a little bit, and now have that as something that shows up as a driver for REHSD, HDMI. And then there is a programmable logic display type of driver, which is the Xilinx PL-DISP, and I'm using that. I'm using some GPIOs. Mostly those are just resets for the frame buffer read. And so then the next item here is this V underscore frame buff underscore read underscore 0. And then there's going to be a 1 and a 2. I've got a few of those in my design. And you can see what the compatible is off to the right. So there's a driver for that has to be loaded in PetaLinux. I've set aside some memory with a reserved memory and 3 different frame buffer allocations there. And then I'm using this timing controller, which you can see the compatible strings there. Again, this is Xilinx, using the Xilinx native driver support. So all of this has built-in support in PetaLinux. You just got to go find the right items to select in your kernel drivers, and then you should be good to go. Now I'm also using, let's see, FB dev. So that's another key item that I make sure I include so that I can have my video output show up as, you know, FB0, FB1, FB2 underneath the devices. Now, stepping forward, if I take a look at this, what I then have done is set up FB0 as my primary output. I then have an FB1 and an FB2. And I've configured all three displays for 1280 by 720, 60 Hertz. And pretty much for the color settings, I'm using XR24, which is equivalent, I believe, to XRGB 8888. So depending on which component you're working with, you've got to give it, you know, the color standards that you're going to support. And XR24, the way I understand that is it's 4 bytes of data. One would be for alpha channel, which I'm not using. So that's where the X is just saying you're not using the alpha channel. Otherwise, it'd be like an AR24. But then I've got 3 bytes of data for the actual color. And that's what these are showing. So like XRGB 8888, I believe, is saying, you know, the first byte we're just going to ignore. The second byte will be red, then green, then blue. But anyways, I want to point that out. So as I get into my DTSI or other things later, it's really important how this is configured, because if those are not configured, things definitely won't work, or they won't look right. Colors will be off. So I'm going to dig into this, and maybe I'll just start by kind of showing what some of this looks like. So I'm going to get out of that. You know, I've got my board running down here, just you know, off of my webcam like I've done in previous videos, so you can kind of see that if I decide I'm going to do anything with that, which I probably am not going to do much there. But then I have 3 other video outputs over here, and the system is running right now, but this is black, probably because it's in kind of a screensaver mode. So I'm going to, on my keyboard that's connected to my Zynq board, just, you know, hit a key, and out comes that primary video output. And this is Matchbox, is the user interface that I'll be using here. So down on my board, I have a USB connector right here, and that USB connector goes out to a USB hub. I've got a keyboard, I got a mouse, I've got some USB storage, things like that plugged in. And I'm booting my system off of a little SD card here. So that's the primary way that I'm working with this. Maybe something else I do have right here is just a good old USB serial. So if you see me use this window here, that's what that is. It's just a USB serial into the board. Then the screen you're seeing up here is this output. If I go up to this output, that would be this one right here. And then the VGA output is the one down here to the lower right. And I'll work with those little by little here, and I'll try to increase the size of these when it makes sense, rather than me trying to record all these separate videos and edit them together. I'm just going to kind of shuffle these windows as I go through this. But I have valid output up here. And so I'm capturing 4 inputs: my webcam, this HDMI, and this VGA. And now if I grab my other mouse that's for my Zynq board, you can see I can move around here, and I can go do things like open up a terminal. And in that terminal, I'm going to actually try to make this a bit bigger here. But in the terminal, I'm going to go in and use a tool that I had written. So it's just called FB Test. And FB Tests allows me to run different tests. And I can run test 1, which is just some colored bars that float down. And what you're going to see over here is I can tell at which frame buffer I want to do that on. So like this one right now would be the main screen. So I'm not going to do that test on that because I'm running Matchbox. But I've got these other 2 windows, and I'll just shrink these so that they kind of fit off to the side here. But when I run it, I'm going to specify that I want to use dev FB1. Now maybe even before I do that, let me break out of that. If I go into the dev directory and I do an ls, you'll see that I have FB0, FB1, FB2. And I can use those now. So when I do an FB test and I say do a test 1, I can say, well, don't do FB0, do a test on FB1. And there you can see it just drops these colored bars on that output. If I run it again, I'll just do FB2. And you can see that output is working fine. So I got the main output, plus I have these outputs all working perfectly fine. Now I'm going to actually get out of this matchbox and just jump out to a command line, a console. And from that console, I can go run FB test. And this is what I've built in there for support so far. So I can do a show config. So I might say, show me the config of my FB0, and it just gives me some information about it. Or I can run it again and say, I want to see how is dev FB1 configured, and I can read through that. And you can see I'm running, as I go through this, I'm running basically a 1280 by 720. My virtual res shows 1440, which means I'm running 2 buffers. So there's 2 vertical, basically there's going to be the main screen, and then there's a second vertically stacked piece underneath it. That is my other buffer. So I've got room for 2 buffers, 2 frames here. So I can write to one while the other is displaying, and then I can swap them and do things like that. But this little utility lets me just quickly, show what that configuration is, read out some data like that. So that's helpful. But I can also do a test 1. So -- test 1. And I'll just do it on this FB0, and then you can see it does its thing, and you saw me run it on the other 2. There's also a test 2, and let's see, let me get out of that, test 2, and I'll run that on FB0, and it's just these 3 little animated sprites that run across, and I'm going to go ahead and break out of that. And I can do the same thing on the others. So if I want to go to dev FB1, FB2, you get the idea. It's just outputting that same thing. I did add in an additional FB test, and that is a test 4. And so it just drops simultaneously the color bars on all, and then it just starts scrolling across left to right. And I've got some tearing going on so if you see I can see it in this, the bottom purple, it shows up with a little black, it's not quite lining up right. Well, that's some tearing. So that's stuff I need to figure out how to improve on. How do I write to the frame buffer and not see tearing, and be able to swap between the frames and synchronize it to the VSync signal? And there's a whole lot there. And this is why I wanted to have multiple outputs, so I could be messing with stuff like this and learn how to do some of this lower level video output control. But once it gets to the right edge of this screen, I just have it continue right into the next screen. And so you'll just see that it just will float across. And as it goes, I'm overwriting, those bars that are there already, and leaving a trail of black. So it's just going to kind of erase stuff as it goes. And when it gets to the end of this screen, it's then going to move on and just kind of continue into the third screen. So essentially, I could treat this as a 3-wide 720p monitor setup if I wanted to. So I'll let that run and just let it at least work its way into the third screen. I think you probably get the idea of what I'm doing there. But basically, I'm having to control which frame buffer does it write to depending on position and things like that. And I think I'm going to write a driver, try to write a driver that gives me a frame buffer number 4 that is just the other 3 combined. And then maybe I could use that as something that PetaLinux would just see as a single frame buffer 4 that would really treat this as a triple wide single screen type of setup. I'm going to break out of that because I'm impatient. Maybe something else I had done in this folder, I have a bars.sh, which just simply runs some of these tests. And it's going to kick off the test 2 with the little animated sprites. It's going to kick off all 3 frame buffers that test simultaneously. And then it's going to start basically doing, let's see, then the next one, the test 1 would be my bars that fall down. So if I go and I run this, you can watch the 3 screens, but I'm going to see there's my bars falling down, and at the same time I'm running the little sprites across the screen. So again, I'm working with all 3 frame buffers. That's all I'm trying to show here, is that I can work with those frame buffers. And my frame buffer 0 is where I'm running Matchbox, so I can flip back to Matchbox. you know, this and wrong mouse, but this Matchbox, it's performing well. So, you know, I can come in here and, you know, use things like a simple text editor if I come over here, and that I've shown in previous videos, but all of this Matchbox stuff seems to be running just fine and performs well, honestly, on this little system. But now I can create multiple terminal windows and do whatever I'm going to do in here. But I've got that. I've got my other outputs. I've not tried to go back and get X11 working with this change in video setup that I have now. And I have not tried to get Weston. So previously I've had Wayland Weston running. I've not tried to go back to it and get multi-monitor support up and going. I don't believe Matchbox, this UI that I'm in right here, I don't believe it supports multiple monitors, but I think Weston does. I just haven't tried to go back and do anything with it. Performance of Weston is not great, so trying to go from 1 to 2 to 3 screens, I can't imagine that it's going to be effective or usable. But Matchbox here seems to be doing pretty well. Okay, so that's the output. Now let me go maybe start digging into what have I done to get all of that working. And let's get all of this out of the way, and I'll start in Vivado. So in Vivado, again, over here, I have my Zynq. I have a couple of clocks coming out of it. I've got 100 megahertz and a 200 megahertz. So anywhere that this clock 0 goes, that's a 100 megahertz clock I'm using. And anywhere that this clock 1 goes, that's a 200 megahertz. So I tried to do anything that is going out to my memory interface. I tried to run at the faster 200 megahertz instead of 100 megahertz. And this Smart Connect and this Smart Connect are letting me get all of my other master and slave AXI devices, you know, tapped into my processing system. Then I've got my processing resets, 100 megahertz sync and a 200 megahertz for those two different clocks. I have a whole bunch of interrupts that are going to all kinds of things over here. And then again, I mentioned that down below, this is all audio stuff. So all of this is audio. And that's my I2S audio, not I2C, I2S audio. And then I get into video, and I'm going to basically take this section and scroll to the right. That is my primary HDMI output. So it ends up over here with an HDMI output, and it starts over here to the left with this component right here. So this is a video frame buffer read. And essentially, it's going to have an AXI control line. So that AXI, I should say line, it's actually many signals. So if I expand it, you can see there's a whole bunch of signals there. But AXI control, that's coming into this Smart Connect. The Smart Connect is jumping down to my processing system. So that's how I can programmatically manipulate this buffer read. It needs a clock, and so in this case, the clock I'm running is a 100 megahertz clock going into it. It needs a reset. That reset needs to come from a GPIO that can be programmed through, again, a slave AXI interface. So programmatically, the driver has to be able to get to a GPIO that can control the reset line of the video frame buffer. And then the video frame buffer has to connect back over here. This is going to connect into my AXI mem, again, then over to the processor. And that's where I'm going to be able to start grabbing basically from, let's say, PetaLinux into this, get memory frame buffer written to, so I have something to output. And then there is output of that video content, and that's going to come over to this AXI for stream to video out. That's going to generate my raw 32 bits of data that I'm going to send out, along with some signals about is the clock locked? Am I in the visible part of the display data as it's as the clock is rolling through the screen, row by row, column by column, bit by bit, and then row by row as it goes down. All of that timing data, there's part of it that is when there are pixels that you see, and then there's some activity that happens outside of that, front porch, back porch, things like that. But that signal is just telling me that wherever I'm at in that whole set of clock cycles is it where I should have data to show on the screen, pixel data, color data. And then I've got this block over here where I'm taking in some clocks, and I'll talk through this in a little bit, but that ultimately gets it into the appropriate signals that I need for true HDMI output. So coming back over here, the other thing that I rolled over was a video timing controller, and this is to basically programmatically be able to choose the timing detail that's going to go into all of this to the right as far as how it's going to generate the video signal. And you have to be really precise on all of this timing and clocks and things like that. So there's a timing out that then comes into the stream to video out and gives it timing detail. And then it, inside of this, is generating things like vertical sync, horizontal sync, blanking signals, etc., and sending out data that I'm going to pass on to this other component to the right. Now, if I go into these, like the frame buffer, I've set this to be max of 1280 by 720. I just chosen 1280 by 720. Anything higher than that just seems to be unnecessary and too much overhead for this little system. I've told it that my data per pixel color is 8 bits. And then I can come down here and choose all the video formats I want to support. And like I said, I think what I'm using on this one is going to be something like this RGBX. I think is probably the one that my system is using right now, or something close to that. But I checked them all so that I don't have to necessarily worry about this limiting what I can use for different color formats. Then I come to the right, I've got the timing controller. I've set this in the graphical user interface, but my device tree will override it if I want, but it's set to 720p for output. And you can see I'm generating a bunch of these signals. And if I look at those signals, they're all going to be passed over here as part of this timing in. So I bring in my timing, I bring in my video data, the pixel data. I've got a reset. There's a clock line that has to come out. Now the clock for all of this is being driven off of just a plain old clocking wizard. And so I am on this bringing in 100 megahertz, and then I'm sending out the speed I need for 720p signal, and then 5 times that. So in this clocking wizard, I have to come in and tell it that I want outputs of 74.25 and then 5 times that. And you really want to pay attention to make sure the actual matches it. If it doesn't, you're feeding in a source clock that it can't derive the very exact speed that you need. So you want to have exactly this. And so in my case, bringing in 100 megahertz, it supports it being, this specific output for actual. So you want to keep an eye on that. And then I enabled the locked so that this signal goes high once this clock is stable. And then I use that locked signal, you'll see in many places, but to say, okay, don't let this timing controller start up until that clock signal is stable. So the clock signal is stable, that locked goes high, it takes this auto reset, and you'll see that type of pattern get used here on some of these components. Then there's this the stream out. Choosing again what video format are you going to use, what are you going to do for a FIFO. There's a buffer, so how big of a buffer do you want? And I would say that right now my system is probably sitting pretty good. If I go to the overall view of it, my block RAM is pretty low right now. It's 25%, so I'm not doing a ton of buffering in this solution. I've got plenty of headroom there to do things with that. But then this is going to connect out. I did put in a little module that just swaps some of the bytes around, because what it was coming out with and what was going into my output over here didn't seem to match the color choices I was picking. So I just put in a little module here that all it does is it swaps the bytes around to get the colors in the place that I want to have them at. I'm sure that can be properly adjusted by finding the right color settings, but I was having issues with some of the Xilinx drivers basically not liking what I thought it should be using, and I would get errors about invalid color formats and things like that. So I picked one and then I just manipulated it myself real quick. And then I've got this component, which you can see says REHSD. So this is one that I wrote in a separate project in Vivado, and basically it just takes in the clock pixels It wraps that HDMI native code that I mentioned before. So it brings in all the appropriate signals, wraps that, feeds it the appropriate data, and then it generates the native signals for HDMI. And, you know, I guess I could maybe open that up and just show you. Let's see. I've been playing around with this custom IP a bit, kind of interesting. But in my Vivado projects, I have a custom IP folder, and I've written a few different things. I've gotten one that goes from DDR straight to VGA. There's this HDMI IP, which I'll open up. There's also, oh, let's see, it's one of these two. That's an older one. This is the one I'm going to go to. I also wrote an AXI to video type of translator, kind of like that streaming. But let me just open up this HDMI driver. And when I say driver, I'm not talking about the software driver for it, but this IP right here is this over here. So basically, it is a wrapper that I wrote that looks like this, and it ends up leveraging this component here. And this is getting into that functionality from that GitHub repository that generates a native HDMI signal. So I did some adjusting to that, and then I've got my wrapper, of course, just to make sure that I'm getting the right information as I work with this. And that all seems to be working fine. And I'll try to post all of this stuff in the next couple of weeks. So if you do want to really dig into this, if that's of interest, you could take a look at that. But that is what I had built that is supplying this component here. Maybe other things on this first HDMI. I do have the appropriate signals for I2C signals, so I can come in here and I can query, if I want to, I can query the monitor through your normal HDMI, I2C to see what does it support for resolutions and timings and things like that. Although I've pretty much hard-coded most of this to 720p, but I do have support for that, and I would have the appropriate I2C, set up in here to be able to do that. And I believe, if I remember right, I'm using this one right down here for that. Yeah, there's my HDMI. So some of that data communication over there. Now, in addition to that, then I come up here, I repeated the whole thing. So I have an entire set of those exact same blocks, just, it's a 1 instead of a 0 at the end of the name. And at the end of that, it's going to a separate set of pins. So that would be on my board here. These pins are the ones going up, out of here, up through this connector, up to this HDMI connector, versus these pins are going over here to this connector. But just repeating the whole thing. And then if I keep going up, I've got some pins over here that are all of the signals that go up here. So there's an H sync, horizontal sync, a vertical sync, and then 16 color lines. So coming up through this, I've got then those 18 signals, and 16 of those are just simply going to this ladder, this resistor ladder here, that is taking my digital and getting me an analog type of signal for the VGA. But what you're going to see on this whole top section is it's the exact same thing again, and same clocks, same criticality of the clock speed coming in being that 74.25. Now with VGA, I don't need that 5 times clock. I just need the 74.25 clock. And if I look at this, it's going to come back. Let's see, this clock, the VGA clock, you can see it's the same clock pixel I use for these others. And all of that, again, was coming off of this little clocking wizard, which means I cannot dynamically change clocks on this. So if that was important to you, there is a different component that I had in here before from Digilent that lets you dynamically choose the clock. And I believe Xilinx has something comparable, but I've just hard-coded mine to 720 at this point. Then I get over here and I've got this little module. Pretty much this stream to video out generates most everything you need for VGA, if not everything. So it's got your H-Sync and V-Sync, and it's got your color data. The only reason I really built this little module over here is I bring in 32-bit color, and I have to compress that down to half the number of bits, down to RGB 565. And so I just had put together this is all it is, right? It's just going to pass through HSync and VSync, which is kind of pointless, but I did that anyways. But then here it quickly compresses, and I basically dropped the low bits of all the color data for the red, green, and blue so I can fit it into 565. But that then gives me this output here. So that's the high level run through all of this. You know, if I go through, you know, each of these components, I'll just pull them up quickly on the screen so you can see how I have it configured. I'm not going to, you know, talk through all of this, but if you want to pause, you can at least look at these screens and see, you know, how do I have these screens configured if you're trying to get the same type of thing going. And so here's my stream to video out. And here's my custom component for byte swapping, which if you want to see that, that is pretty simple also. Just simply is grabbing the byte data and putting them into a different order to match what I need to see for my output. And then this component was on that other project. So with all of that, I can then go through and generate the bit stream. I can export that bit stream. I can pull it into my PetaLinux. And in PetaLinux, then I need to make sure I have my device tree set up to support all of this. And there's a lot of detail there that you have to get just right for this to work. And again, I'll get this posted so you can go through this if you're interested in the detail, but I'll scroll through this and just talk through what do I have. So this is my current DTSI file. And as I go through this, and I can probably zoom in here a bit, make that easier. You know, I'm coming in and setting up my boot args. In my boot args, a couple of things that are probably important here is I am setting up this CMA. So basically for reserving contiguous memory access or something like that, 256 meg, I'm setting aside for that. And then I'm configuring my 3 video connections, HDMI A1, A2, and VGA1. They're all being set to 1280 by 720, 32-bit at 60. And then I'm telling it that my console should be on that first output. If I change this to a 1 or to a 2, that will shift where everything goes on my boot to a different output. I think I've got all this reserved memory set up correctly, so I've said I want to set up some reserved memory. And then in that reserved memory, I just specified these locations. So I put an 8 meg buffer here, here, and here. And then if I keep going down, let's see, that's USB, my USB PHY. I'm going to keep on going. I then set up my first HDMI output with my driver, and that driver just looks something like this. So this started out from Cosmin, if I'm pronouncing that correctly, working for Digilent, had written a driver. Pretty much I grabbed that driver, I've tweaked it a little bit. The big things that I would have tweaked is at the bottom, you know, I tell it to look for this string. And so if any of the device tree items show it for compatible, this is the driver that gets loaded. Changes I made in this driver really was, you know, take out some of the stuff that does reading of certain settings from the device tree because I don't need it. I'm going to just lock it into 720p. I also tell it not to do the I2C check because if I don't want to use that I2C on the HDMI to dynamically look up resolutions of the monitor, which I'm not doing, I can just say skip that. And then I also tell it not to look for the clock. So it's looking for a certain clock by default. And I'm saying I don't care about that clock because I've done the clocking not with Digilent's dynamic clock generation. I've just used a clocking wizard. So I did not need to do this. And then I've just set it to say 1280 by 720 is the default and the max when it comes to the different video resolution. And otherwise, I think this driver is pretty close to the Digilent one. And again, I'll make sure I get this posted so you can see if there are other differences there that you'd want to pay attention to. But I set that up, and this really is, you know, corresponding back to, let me get it back up, the Alt tab in Linux every once in a while just doesn't work right, but that's corresponding to this here. And so I've got this, and that is really connecting up and getting my driver. And, you know, I don't understand maybe all those details perfectly, but it does get it in so that I can load up and have access to the DRM within PetaLinux so that I can use that, really that pipeline, that video pipeline. So then I have that, and then with that, I'm leveraging this Xilinx programmable logic, their functionality, and this is what that device tree, I guess, chunk looks like. I've got to point it to what is it using for direct memory access, and that's going to be that frame buffer, which you'll see further down. I've chosen my format for the video, or for, you know, the color type of data. I've told it where my timing controller is, and I've had to create a port, and that port I point down to this up here, and vice versa. And basically this is just connecting the two together. So these two are going to be connected together so that these load, and it knows that it uses my driver when we get to this DRM, DMA type of stuff. So then I repeat that process. I have a second one. I got to pay attention to, you know, any of the endpoint names here and make sure that these are tied together correctly. And here's a pair that are unique from this pair here. It also has its own frame buffer. So this frame buffer, this was 0 up here. This one is using one called frame buffer read 1. It's using a separate timing controller. I then repeat with the third one here, which is my VGA. So it's the same thing. I'm using the exact same driver. I know it says it's an HDMI driver, but for my purpose, it works just fine in getting everything in the pipeline running for my VGA. I don't specify any I2C stuff because there is no I2C for querying on my VGA side of things. I tell it what clock I'm using. This is a clock that I set up, and if I go to my files over here, I can go to constraints, and here's my VGA, and I create a clock called VGA clock. And that VGA clock is one clock I can use, and actually in this case I don't think I'm even using that anymore. It's an input I have way up here that I'm not even using. I ended up switching that. I had started out with 640 by 480, but then I later changed it, and the clock it's using is this same clock here. So I probably actually need to update this. This clock for my VGA should probably show the same as what I have up here. So I probably should go through and correct that. Now again, remember in that driver, when I get to this, I'm not looking at the clocking info, so it really doesn't matter. But I think to be more precise, this shouldn't say VGA clock right now. It should probably be listed with this clock information up here. But then I keep on going. Let's see. This would be my, this is I2C related to my audio, so I'm going to skip all the audio stuff. Then I have 3 GPIOs. So those GPIOs are paired up with the frame buffers for the resets. So that's where I get my reset line. And this is just setting up those GPIOs. So again, got to be very careful about what address is it at. And in Vivado, I can go to my address editor and I can find those GPIOs, and I can find the addresses right here. So in the device tree, just make sure that those all match up if you're going to specify this information. So I've come and put all that in, and then I get down to my actual, here's my video frame buffer read. I've got a 0, a 1, and a 2, and that's corresponding to what you see here, which is my 0, my 1, and my 2. And this is what that configuration looks like. And so I have to specify that this DMA cells, and then clock. Have to be very careful with that, make sure that that does match. Same with that, what address is it at? You know, this would be representing 64K, but I got to make sure that those are set correctly. You have to point to the reset GPIO here and make sure that you get that in there correctly. with this syntax, which is, I think it's just saying use the first basically interrupt line coming out of those GPIOs, because you can't come in here and have a second. But I think I've got that all configured right. I've got my height and width, and then I kind of repeat for these other two. Again, these are all probably using the same, clock coming into them, which actually is this one here, this clock C15. You got to make sure that these strings look good, and have to set up this reset GPIOs. And I think you also have to have GPIO names of reset in there. I found with the driver, it was expecting that, so I got that put in there. And you got to make sure your interrupt number is correct, which is always a little bit tricky to make sure that you've got that right if you're going to put it in here. Now, I do know when you go out and, I build all of this and I bring it into PetaLinux, I can go in and let's see if I can find this. So in my PetaLinux project spec configs, let's see, is this the right one? Nope. I might have to do a search for it, and none of those. Hardware description, no. Let me just search, unless it's meta user config. No. Oh, actually it's up in components, I bet. Components, there we go. This right here is created when I bring that into PetaLinux from what was exported for the bitstream over here, but I can search for these things in here because it might already have that information, which means you don't need to specify it. But like if I grab this frame buffer and I'm looking for it, here's what it had generated in here. So I had chosen all those video formats, I put them all in here, and this is where I can just validate the interrupt. So this is showing, this is kind of the source of this information. And my understanding is then over here, if I put in this, and ampersand in front of it, that just says, okay, this is referencing this other thing, and any values I put in here can override the values here. And I think in a lot of cases, if the value over here is correct, you don't even need it over here. So like this one with the interrupts, I think I could even get rid of that, and it should pull it from here. I could be wrong on that, but I did list it out here just so I have it. And I think then that just leaves the timing controller, and this is how I have those. So again, timing controllers each have an address, so you got to come back to Vivado, make sure you look at the address editor, grab the timing controllers, get the right address, and then get that put in here, and make sure you got the appropriate compatible strings in here. But that's a lot of stuff. And then I guess the rest of this, I've got some other, I2C one is for my real-time clock. Another one is probably used for my HDMI stuff. I've got some SPI set up, but that's the extent of my device tree. So there's a lot of stuff there, and that might not be detailed that you're overly interested in, or if you're still watching at this point, it's maybe because you are trying to dig into this a little bit. So I've got my DTSI, I create and build my PetaLinux package, and then that's given me, this type of output that you're seeing over here, which I'm probably in screensaver mode again. And that is all working. So I think that's a lot. I'm probably going to wind this down here. Hopefully that's helpful. Again, my goal was to get back to having, 3 outputs that I can access as frame buffers, from PetaLinux, and I can get out of this and, go do things like, let's see, I'm getting out of Matchbox, other tests that I have graphical wise. You've all seen me run. I can go back into and run FB Doom. And just make sure that all the graphics work there. And I tested this earlier, and all of the graphic output here, still continues to work fine. So not a big deal on that. And for some reason that kicked out. I don't know why. Yeah, it acts like it lost the capture of my keyboard in there. I don't know why. Yep, and now my key mappings are a little off, which is interesting. So can I get back into, I can't. So something got a little messed up there. I've not seen that. I think I might jump over here and just reboot. Should see that as it reboots. Yep, it cleared those. Okay, as it's booting up, we're going to see that there it loaded my 3 drivers. It's connecting the DRM. It's giving me my FBs. So I just happened to catch that as it's scrolling across. Back here, it's, please wait. It's booting up. Should take me into Matchbox. I'm going to kick out of that. And I will eventually get this. User bin, and then FB Doom, iWAD, Doom 1 WAD. Okay, we'll try it again. And I do not have my audio stuff loaded, so I could be screaming about my audio, and maybe I would have to fix that here real quick. Yeah, it's kicking out. I think it's because of audio. So I'm going to do something here. I've got a little script that does some initial configuration of my system. I've not run that on this. This was a new clean image, so I'm going to run that real quick. I was just making sure I haven't broken something along the way as I switched out all of this video stuff. Okay, also mixer looks good. Okay, you probably aren't gonna be able to hear that on my mic pickup, but just playing some music, that all tests out fine. And now I'm gonna go run Doom. And just see if that was the issue, that it was trying to connect to my audio and not working right. Or if I have something else here that I need to go. Yeah, okay. So that's working fine. I think what was probably happening is that it was trying to connect to my audio server, which wasn't configured because I didn't copy over the configuration file. Okay, good enough. Get back out of that. And I'll do a clear on that. So that all seems to be fine. So far, I think I'm good to go on what I've got. Audio's working. Video is working across all 3 frame buffers. Again, I have these 3 that I'm working with. But the gist of it was really swapping out the virtual DMA component that was here and putting in this video frame buffer read, getting everything wired up correctly with that, getting all the right reset signals, lock signals, frequencies set right, and ultimately getting good signal out of all of these. So I think I'm good with having those up and running. Now I can spend some time learning how to work with frames and syncing my frame updates with the actual frequencies, the vertical syncs, things like that, trying to reduce tearing, all kinds of fun stuff I can be doing there. And then I'll be digging into more of the programmable logic side of working on video type of stuff. So I have a tremendous amount to learn, and we'll be starting from very little on that. So I think I'm probably an hour into this, or approaching an hour. So I thank you if you're still watching this. If you've got questions, feedback, thoughts, things that you want to pass on to others and myself as far as tips, drop a note down in the comments of the YouTube video. Thanks.